It's interesting how when I touch my finger to this wire, just feeding the LEDs, they light up even just a little bit, and that's obviously the mains, the mains hum capacitively going through my body and into the wire, and obviously to ground through the power adapter wire. And if I unplug that, you can actually see that it doesn't do it anymore. So yeah, it just goes to show that these LEDs can light up with very little current, which is useful because I want to use as least current as possible, since we are running the entire thing off LR44 cells and they don't really supply much power. But yeah, we've got the thing set up here. I've just been testing 2 sets of LEDs with 2 sets of resistors. I've got 150 ohm resistors here and 220 ohm resistors here, and yeah, the current draw is slightly higher with the 150 ohm resistors, about 12 milliamps per LED, and the other ones are about 8 milliamps per LED, and the brightness is pretty much exactly the same. You can't really tell the difference at all, so that's really useful. I mean, if I just disconnect that one, you can see it lights up the bench, lights up things really well. Definitely good for an inspection sort of thing, light, and just looking into corners and crevices and under boards and stuff like that. If I turn that one off and plug this one in, you can see that's pretty much exactly the same. So I mean, I honestly can't tell the difference with my eyeballs, so yeah, I'll just go for the lower current version of the 220 ohm resistors, because we want to have as highest battery life as possible, obviously, and obviously and of course the less current we push through the LEDs or whatever, the less current we allow them to draw, then the longer they're going to run for, the cooler they're going to run, and yeah, that's just good. So I'm going to do that. So yeah, I'll switch this all around and we'll get some different shots of this thing, and I'll put everything together and see how it goes. And here we've got the LEDs hooked up. I've got my ammeter hooked up. So on the 220 ohm resistor set over here, we've got 8, nearly 9. So I think the connection's a bit dodgy. Let's just pop that in there. Yeah, so almost 9 milliamps on that one. And if I just switch that over to one of the other ones from the 150 ohm set, we'll see there's a slight increase in current there, but what have we got here? About 12 milliamps. That's sort of, yeah, these things are a bit dodgy in a breadboard. You're not going to get a great connection here, but yeah, what have we got? 12, 13, oh there we go, 13, yeah, that makes more sense now. 13 milliamps between that one, but yeah, I can't really tell the difference, not visually anyway. So yeah, it's not an issue. We'll just run with the higher resistors and the lower current draw, which, as I said before, is much better because we're using really tiny little cells and they're not going to have much current capacity to start with. Alright, so time for some live soldering, and we'll see if I can do something silly to myself or to the LEDs. So first of all, I've got to disconnect the little wires, which I had already put. Hang on, let's get my soldering iron cord somewhere that's not in the way of everything else. No, that's not going to work. Hang on. Put that over there. Okay, that's a bit better. Now, just after waving a soldering iron around wildly. So I just got to take these wires off because obviously these are in the way. And we can take those off. Now, so I need to remove the old LEDs, and I need to remove the spring to get at the old LEDs. So first of all, I'm just going to need to move that little piece of wire I had on there before as well, that other little bit on the side, because like I said before, there was basically no connection between the torch body and the well, actually it was the positive side of the PCB instead of negative, because why not, and it was just between the like thin copper edge of the actual copper layer, then that's all there was. So I tacked a little piece of wire on the side. It made a much better connection before. But you have to take that off. And let's see. What else? How's this soldered on? Looks like that spring's just been put on, just tacked onto one of those LEDs. So let's take that off, and we'll see if that'll come off. There we go. Okay, so let's just put that out of the way there. Now, to remove these LEDs, I'll use my desoldering gun. Just warning about the noise here. So alright, that's one. And that's two. And that's three. So we've removed these LEDs now. And those pads are good, but the other ones are going to need a little bit of cleaning up. So I'll just get some solder wick and put my desoldering gun to the side so I don't burn my fingers on it or anything else. Now let's get some desolder wick and flatten those pads, because it's always a really good idea to work with pads that are actually flat and clean and don't have big blobs of solder on them. Otherwise it's just really a pain and you're not going to have a good time, basically. And yeah, I'm running out of solder wick, so I need to get some more of that too. I've got that much left. I went to JCar the other day when I was getting the LM317 for my emergency New Year's Eve or whatever. Yeah, it was New Year's Eve, I think. Emergency New Year's Eve dash to JCar for an LM317 to finish off my friend's TV backlight inverter modification project. And I asked them for some desolder braid, and they didn't have any, so that wasn't very good. And they claimed that they never had any cheap stuff, which is a lot of lies because it's all over their website. Yeah, I didn't really see any point in getting the expensive stuff at twice the price, because this seems to work just fine, and it's the stuff I've been using for ages. I mean, I used to buy it from Dick Smith, but as we know, Dick Smith doesn't sell anything good anymore, and Dick Smith kind of went bankrupt and all that or whatever. So yeah, so anyway, I've cleaned the board up a little bit, and now it's time to do some to get medieval on it. So I'll just grab a knife here, because I don't have a proper tool for this, or I may do actually, lying around somewhere in a box of stuff, but it'll probably take me 50 years to find it, so I'll just use a pocket knife. Now, my basic plan here, I'll just point with this knife, because why not? My basic plan is to solder the LEDs back on here, and then I'm going to have a resistor going from this pad to the LED pin here. But obviously we've got a PCB track here, so if I just solder the resistor there and the LED, well, the resistor is going to be shorted out by the actual PCB track itself, so that won't do anything useful. So I need to cut this track so that I've got something to actually so the resistor is actually in circuit and not shorted out by the track. So the best way, I mean, I could cut this here, and yeah, but I don't know, I think the best way is just to let me think. No, I think the easiest way is just to drill. Use a drill, actually. Okay, with the magic of video editing, I now have a drill bit. And I'll just cut some of this off. Now, I think I'm going to have to cut that Actually, if we don't cut the edge, that'll help. Yes, okay, so let's just cut the pad off for the LED. Just cut around there. So yeah, you can easily cut. I mean, you can get like spot face cutter tools that probably don't take out as much PCB material, but that's not the point. I just want to do something quickly. So, and this thing doesn't matter. It's just a cheap torch. Now, if we get the new LEDs and pop them in. I hope this is on camera, by the way. I have no idea if it is or not. Because unfortunately with the webcam there's no monitoring. Or at least I can't get any without the frame rate dropping to about 5, so it's not... I'm basically doing all this blind, it's hilarious. But yeah, so if I just solder these in like this... maybe I should... No, it's going to be a bit futty, isn't it? Futty. I don't think that's a word, but it is now. Alright then. Some solder. And it falls over. This is probably where the helping hand thingies would come in handy. Let's get that. I should have those resistors out of the way. Yeah, this is terribly messy. I'm trying to do a rush job of this actually, and it's not really that great, is it? Maybe I should slow down and stop being ridiculous. But anyway, let's just tack those in there like that. And yeah, this is all completely on a wrong angle and everything, but I'm going to fix that in a second. Yeah, no, let's just leave it like that. That's great. No. I'm going to push that up through there. There we go. Okay, now those joints will be terrible and all cracked probably because I've just gone and moved them all while I'm soldering them, but I'll reflow them again later and it'll be fine. So let's cut those leads off anyway. So they're out of the way. This footage is probably not that great. Unfortunately, sorry about that, but it's just to show the basic principle. Now, what's the idea? So I need to take a resistor from this lead to this pad, basically, and the idea is I've cut this pad out so now there's nothing to get in the way. So if I just take off the lead just to about here, just take off a little bit, I'm just leaving a little sort of little short bit there. You can probably see that, just a little short thing. I'm not sure, hopefully you can see that. I'll point at it with a drill bit. You can see that we've got the LED just free in a cleared out hole and it's not connecting to anything, so, and that's where I'll attach my resistor. Now let's see indeed. See the best way of doing this. It's probably to solder the resistor on the other side first. Therefore that's what I'll do. That's a bit dodgy, isn't it? Okay, so gotta try and find something that'll hold this quite well. I think I need the other ones. I've got another set of these things, little clampy things. Oops. These are the different type with the heat shrink on them. Wow, this is very tricky, isn't it? It's just typical. Okay, so we'll just hold that about... God. We'll just hold that about there. Should work. Hopefully you can see this. This is not very good. That's better. Should have just done that to begin with. Okay. Anyway. Got myself a resistor. And now I can see that if I cut this off about there, I should be able to take some fine pliers and just bend this around. Just round and down and just pop it into there, right next to that, right next to the LED lead. Now again, I hope you can see this. I should probably take a an up close shot of this, but I don't have my camera next to me, so too bad. I'll take a final one later. Yeah, I don't know if you can, how well you can see that. Hopefully you can see that. It should be fairly obvious the way I've done this. Just taking the LED lead and the resistor lead, and I'm just going to tack them basically directly onto each other, so the PCB will not be anywhere in the equation. And there we go. So the LED now goes, takes power from this. That's where the spring will connect. It'll go through the LED, up through here, through the resistor, and to, well, to positive, because these things are wired backwards. Well, not backwards, but the torch is wired backwards. I mean, basically the positive supply goes onto the torch body, the negative goes to the spring, which is kind of backwards to the way torches usually are. But anyway, it doesn't really matter which way around they go, because it's, yeah, just a torch. But yeah, so I'll just repeat that for the next 3 LEDs. Next 3 LEDs, what am I talking about? The next 2 LEDs, I should say. Now this isn't going to look very pretty at all, but that doesn't really matter, because that's hardly the point. Whoops, that didn't actually solder. Yeah, it's kind of hard when you've got a camera in the way of everything. Actually, hopefully this is actually in the shot. It would be funny if I just shot this entire video and everything was out of frame. Actually, it wouldn't be funny, it would be a bit annoying, but it would be funny in an ironic way. Wouldn't it? Okay, 2 resistors done and 1 to go. I mean, this camera is a wide angle lens, but I don't know if it's that wide, so yeah, I should definitely be trying to keep everything over here, so to maximize chances of you actually being able to see what I'm doing. After all, that is the point. If you can't see what I'm doing, then it's not a very good video. And I'm sure everybody is laughing at me for my terrible, terrible camera work. Anyway, I'll just leave this one here with a slight tail on the side there so that I can bend that over and ensure a good connection to the side of the torch body, because that was the problem with it before. Now, final LED resistor. Might have made more sense to use tweezers here actually, but anyway, whatever works, I guess. Make sure this is aligned well and not shorting out to anything, because that would defeat the purpose, as I explained earlier. And I wish I could come up with some sort of better commentary than what I come up with. Then again, maybe there's nothing wrong with my commentary. I'd be grateful for comments and feedback about how my commentary is, and to see if it's any good. Alright, so that's all done there. Hopefully you can see that. Bit of crusty flux residue, but again, that's not really going to make much difference. So, can you see that there? Hope you can. Where's the reflector? Oh, it's in the end of the torch. Right. Okay, well, I better start taking the torch apart again. That's the fun part, isn't it? Well, it's not really a reflector, it's just a sort of reflector looking end cap thing that doesn't really do much. Okay, just holds the LEDs and looks pretty. So that fits over there. So that's good, they all fit there, which is what we want. Now, what am I doing? What am I doing indeed? Just bend these switch contacts, they were a bit sort of squashed after all my poking and disassembling and stuffing about. So just want to make sure those have some good springiness on them to make sure we got some good contact. Now let's spring indeed, the spring. We need this spring back here somewhere. Now, how's that going to work? Let's just try to solder it like this and see what happens. That kind of works. I think I'll need to use pliers though. That's quite a bit wonky. Huh. Yeah. Well, That's on there pretty well though, so should be alright. Just make sure it's connected to the other LED joints. I mean, hey, we got a wonky spring, but I mean, this is a wonky torch, a wonky cheap torch. So, a wonky cheap torch. No, a torch. Yes, a torch. Yeah, whatever. Wonky spring on a wonky torch. Doesn't really matter. So, actually, no, I will take an up-close photo here, just in case. So, 1 second, we're back with the camera. Yeah, this is a very hasty and rough video. I'm sorry about that. But it's just something quick I want to finish and get out of the way. So yeah, hopefully you get the idea of what I've done from these photos, and hopefully everything makes sense. And hopefully you can do the same sort of thing yourself if you have one of these torches and wish to make it work. So let's see, let's put the thing back together. Oh yeah, we need that little bit of plastic, don't we? Where did that go? Ah, there we go, it's up there with the rest of it, or where the rest of it was. So there's slots in there, doesn't it? Just push that in there. And push that in there. And that holds the switch in place so it doesn't fall down when we poke it. And the LEDs go here. Boop. And I got myself some fresh LR44 cells. Were those the fresh ones? No, hang on, maybe these are the fresh ones. Let's have a look. No, those are the old ones. They were called soda. I don't know if you can see that. Soda. Maybe they're made out of lemonade. I don't know. Maybe that's why they don't last very long. The new ones I've got are NL. Don't know if you can see that. NL. Don't know what that means. No load. Who knows? Anyway, so these will go in backwards because negative is the center part, and the screw goes on. Oh, look at that. It comes up because I've pressed the button. Let's just switch that off for a second and put the end bit on. And there we go. Turns on. And it works. And it's blindingly bright if you look at it in the wrong direction. But, yeah. We can look at things. We can illuminate stuff. Look at the old LEDs there. So yeah, all three LEDs are working. They're all bright and they're all not flickering. So let's just play around with this. Shine some light through a bag of LEDs. What does that look like? Some sort of freaky sort of LED bag of stuff. Anyway, great. So that's what I wanted. A torch that doesn't flicker and works and has current limiting resistors for the LEDs so they don't blow up and all that. So, so I should test the current draw from these things. Let's find out what the final current draw is from these three LEDs with their 220 ohm resistors on them at a 4.5 volt supply from 3 LR44 cells. So hopefully if you can see my meter, you can see that we're drawing about 14.5 milliamps. This is with the old cells, so with fresh cells I'm sure it'll draw a little bit more current. In fact, we could probably just try that out right now. But basically, yeah, the LEDs are drawing about 5 milliamps each now. Obviously the supply voltage of these batteries is slightly less than the bench little supply I had hooked up previously. So yeah, that was 5 volts. This is 4.5. We're going to get a bit more current through that with the higher voltage, but at the yeah, okay, we get 18 milliamps with fresh cells. Brand new cells get 18 milliamps, and with half flat ones we get 14. But yeah, I mean five or so milliamps, 5, 6, 7 milliamps per LED, and it's still really bright and really useful. So I'll just put the old cells back in because might as well just use them up before we go on to any new ones. But yeah, that's pretty much it. I mean, it works, and it works well. No flicker like we had before. It's really bright, and yeah, I mean, I can just grab stuff and look at it, and yeah, great for inspecting solder joints and whatever. You know, looking inside things, and you know, getting into you know, looking under plugs and stuff. I can, you know, get a good sort of view under things, and of course, if I take my loop as well, I can get right up there and check, you know, part numbers on ICs, surface mount stuff, and yeah, it's really good. So hopefully this will be a great addition to my workbench and a nice little torch that I can use. But yeah, just goes to show, I mean, I don't know, well, they probably took out the current, they probably didn't use current limiting resistors in the original design just to get the thing as bright as possible, but doing that, it draws, you know, about 40 milliamps per LED, and that's for cheap 5mm LEDs. You know, they only generally run at like 20, 25, 30 maximum milliamps maybe. It's not really that great. I'd say that's why one of them failed and they all started flickering and going a bit funny. But yeah, kind of sad really. I don't know why they didn't just put resistors in. I mean, these resistors, I bought these from RS, Japan made ones, good quality. They were really cheap. I mean, there's like 20 or something in a 10 or 20 in a bag, and they were like $1 or less or something. So you know, China can make resistors cheaper than that, I'm sure. There's not really any excuse for not having a design with a decent design. I just don't get it. But oh well, you know. Anyway, what's there to say? The thing works now. Hopefully it'll continue working, and that's it. We're done. See you next time when I fix something else, hopefully, or whatever happens. So yeah, see ya.